Hey everyone, welcome to episode 15 of our Neet Chemistry series for 2025 and 2026. I'm Chongtham David, your mentor, and with just 16 days left for Neet, now is the time to strengthen your core. Today we're going back to where it all begins, some basic concepts of chemistry. From mole concept to stoichiometry, this episode will guide you through 45 essential questions that form the backbone of problem solving across the entire syllabus. Here's a thought to fuel your preparation. A strong foundation doesn't just support a structure, it defines how high you can rise. Build your base strong, and everything else becomes easier. So let's cement those fundamentals and keep the momentum going right up to the finish line. Now let us start solving some questions. I'm going to share the screen for you. Let us read the first question. Given the numbers 161 centimeter, 0.161 centimeter, and 0.0161 centimeter, the number of significant figures for the three numbers are. So it has three significant figure. When 0 is to locate the decimal point, it is not considered a significant figure. So here you have 3, 3. This is not considered. So in each of the cases, we have three significant figures. So 3, 3, 3 respectively would be the answer. So option C would be the answer to question number 1. I hope it is understood. Let's read on the next question. Number 2. If the true value for an experimental result is 6.23 and the results reported by three students X, Y, Z are such that X correspond to 6.18 and 6.128, Y 6.20 and 6.023, Z 6.22 and 6.24. Which of the following option is correct? So this both y and x are neither possess precise nor accurate, as the two values in each of them are not very close. So with respect to x and y, the values of z are close and agree with the true value. Hence, both precise and accurate would be the answer. So option D, both x and y are neither precise nor accurate. Z both precise and accurate. So D would be the answer to question number 2. Moving on to question number 3. Number of grams of oxygen in 32.2 gram sodium sulfate decahydrate is. So the molecular weight of sodium sulfate decahydrate is, this is, it has a molecular weight of 322 grams. So which contains 224 grams of oxygen. So what we can conclude here is 32.2 gram of this sodium sulfate decahydrate will contain 22.4 gram oxygen. So I hope it is clear. The answer would be option C. Moving on to the next question, number 4. 3 gram of an oxide of a metal is converted to chloride completely and it yielded 5 gram of chloride. The equivalent weight of the metal is. Now there's a relationship that you have to find, the relation between weight and equivalent mass. So what was the formula? Weight of, I will write it here, weight of metal oxide divide by weight of metal chloride. Let us say M chloride stands for weight of metal chloride, then the upper one is the oxygen or metal oxide. So it equals to equivalent weight of metal plus equivalent weight of oxygen. So take the sum of these two and divide by weight of the equivalent weight of the metal, equivalent weight of metal plus equivalent weight of chloride. This will be the answer for this. So how to arrive at the conclusion? We can say that this weight of the metal oxide is given as 3 gram and 5 gram each. So 3 by 5, we haven't got the value of this metal. So let us consider E, and oxygen you have. The equivalent weight of oxygen is, it is 8 atomic mass. 8 E plus 35.5. Now you can easily find the equivalent weight of oxygen by dividing with the valency. So 35.5 E and E plus 8 corresponds to the weight of the metal oxide with respect to the metal chloride. Now if you calculate this, you will obtain the value of E. Transpose this on this side. 3E plus 35.5 into 3 equals to 5E plus 8. So 2 divided by this would correspond to 33 approximately. So 33.25 would be the answer to question number 4. Let us read question number 5. A 1 centimeter cube of nitrous oxide at normal temperature pressure would be. A normal temperature pressure 22,400 centimeter cube of nitrous oxide, or it contains Avogadro's number of particles or molecules, which means 1 centimeter cube of this nitrous oxide would contain Avogadro's number divided by the volume. That's the required way of how to calculate the answer. So 1 centimeter cube of this laughing gas, nitrous oxide, equals Avogadro's number. Divide this by 22,400. So when you calculate this answer, the value, you have 3 into 6.022 into 10 to the power 23. Divide by 22,400, because we are taking the number of atoms, the atomicity. So it corresponds to 1.8 divided by 22.4 into 10 to the power 22. This much atoms would be the answer. Now number of electrons the molecule will be, let me write it here. Electronic number would be 7 plus 7 for 2 nitrogen and 1 oxygen. So it gives 22. Again, you multiply this number with Avogadro's number and divide by 22,400 into 22 electrons. So this would give you your answer, which will be approximately 1.32 10 to the power 23 by 2 to 4. So 5 would be option D. All of the above would be the correct answer. Question number 6. One of the following combination which illustrates the law of reciprocal proportion would be. So in the law of reciprocal proportion, the two elements combining with the third element must combine with each other in the same ratio or multiple of that ratio of sulfur and oxygen. So when the sulfur and oxygen combines with carbon, it is in the ratio of 2 is to 1. That is, the ratio of sulfur and oxygen in sulfur dioxide is 1 is to 1. So C would be the best answer. Question number 6. Question number 7. An aqueous solution of oxalic acid dihydrate contains it's 6.3 gram in 250 ml. The volume of 0.1 normal sodium hydroxide required to completely neutralize 10 ml of this solution will be. So use the normality equation. Normality of this oxalic acid would be 6.3 into 1000 divided by 63 into 250. So you can easily cancel this. 1, 0. So the answer would give rise to 0.4 normality. Now from normality equation, N1 V1 equals to N2 V2. So simply substitute the values of N1 V1 equals to 0.1 into volume. So what is the answer? Volume will be equals to 40 ml. So D would be the answer for question number 7. Question number 8. The density of 3 molar solution of sodium chloride is 1.252 gram per liter. The molality of the solution will be. So you know the relation between molarity and density. It can also be written as density equals to molarity 1 by molarity plus molar mass by 1000. So on putting this value, you have 1.252 as given in the question. This is the density equals to 3 molar, concentration 1 by molality. We haven't got the value of this, so just put it as it is. And 58.5 is the molar weight of the solid divided by 1000. On solving this, take the LCM. 3, so this would be approximately 5 to 1 by 20. 3 into 1 by 20 would be, so multiply this with again with 1.25. Approximately you would get the answer to 2.79 molality. 8C. Question number 9. The number of atoms in 0.1 mole of a triatomic gas is. So the number of atoms in 0.1 mole of a triatomic gas you can easily calculate by using this formula. Avogadro's number. So 6 3 is 18, approximately 1.806, 10 to the power 23. So the answer would be B. Question number 10. Match the column. So what is the best match for this? Question number 10. It would be A would be match with this is for 2 mole. B, this is for 1 mole. C, this is for 0.25 mole. D, 3 mole. So A2, B3, C1, D5, E6 means option A is the answer for question number 10. Question number 11. The simplest formula of a compound containing 50% of element X, atomic mass is 10, and 50% of Y, atomic mass is 20. So for this 50% of X, atomic mass 10, 50% of Y, atomic mass 20 means the relative number of atoms of X, I can write here, it corresponds to 50 by 10. So this would be the relative number of atoms of X. And for Y, you can say 2.5. So the simple ratio would be divide both sides by 5 and divided by 2.5. It would be in the ratio 2 is to 1. So the formula would be x2 y. C would be the answer for question 11. Moving on to the next question, number 12. Which one of the following is the lightest? Zero point 0.2 mole of hydrogen gas. Avogadro's, okay, 6.022 10 to the power 22 molecules of nitrogen. 0 0.1 gram of silver. 0.1 mole of oxygen gas. So weight of hydrogen will be equals to, we can calculate like this. Weight of hydrogen gas is mole into molecular weight. 0.2 into 2, which would be 0.4 grams. This is the first way. The second method is Avogadro's number 10 to the power 22 equals to, this is 1 mole. So weight of nitrogen would be 0.1 into 28. This is 2.8 gram. Next, let us calculate for the third condition. Weight of silver, it is given. It is equals to 1 gram, 0.1 gram. And weight of oxygen would be, oxygen weight would be 32 into 0.1, so it is 3.2 gram. So from this given option, 0.1 gram of silver, this would be the answer for question number 12. Question number 13. If Na is Avogadro's number, then number of valence electrons in 4.2 gram of nitrite ion is. So moles of nitrite ion we have to calculate first. Let's see. Moles of nitrite ion equals to, it equals to 4.2 by 14. So it is zero point 0.3 mole. So zero point 0.3 mole equals to zero point 0.3 into Na times nitrite. Let me write here ions. So valence electrons, let us find again. Valence electron equals to 8 into this much value of zero point 0.3 Avogadro's number. So 2.4 Avogadro's number. Can I say it is 5 plus 3 due to the charge, and 1 nitride ion remains. It contains 8 valence electrons. So 2.4 Avogadro number is the answer for this question. Question number 14. The set of numericals coefficients that balance the equation. Potassium dichromate is mixed with HCl. Chromate is mixed with HCl to form dichromate. Potassium chloride and water is. So balance equation, let us balance this. If I write here 2, 1, 2. I hope the given sequence is balanced. 2, 2, 2, 2, 1, 2, 1. Sorry, I 2, 2, 1, 2, 1. Where is it? 2, 2, 1, 2, 1. Option A. So I hope it is understood. Just balance and put the coefficients. Question number 15, match the column. So which is the correct page? Let's see, terminal zeros. These are not significant. If there is no decimal, that is 290 contains two significant figures. Whereas in 29,900 there are five significant figures, and in 1.23 into 1.331 equals to 1.6371. But keeping in mind that 1.23 has only few significant figures, there is only up to three significant figures. So this result should also be reported in three significant figures only. Thus, this 1.6373 should be rounded off to 1.64, and the value of 1.783 is rounded off to 2. So it has only one significant figure. So now after matching all this, let us match correctly after analyzing thoroughly. A match with 5 significant figure, right? I hope this is understood. And B match with 2 significant figure, and this C match with 3 significant figure. D match with 4 significant figure. E match with 2 significant figures. So A5, B1, C4, D3, E2 means option B is the answer for question 15. Let's read question number 16. The maximum number of molecules are present in which of the following? So this number of molecules in different cases we have to find. First of all, let us say for A, this 22.4 liter at standard temperature pressure has how many particles? 6.22 10 to the power 23 particles. What kind of particles is this? Hydrogen gas. So 115 liter means, if you know the unitary method, you can easily calculate this 10 to the power 22 divided by 22.4 into 5. So let us see what is the answer for this. It should be 15. So roughly 6.335. It will be less than 5, 4. 4.03 10 to the power 23 molecules of this hydrogen is obtained. Again, this 22.4 liter STP contains Avogadro's number into nitrogen. So 5 liters STP contains, again, the 5 liters STP contains 5 by 22.4 into Avogadro's number. So this value is, after calculation, approximately 1344 10 to the power 23. And 2 gram of helium means 1 Avogadro's number. So after comparing, this 15 liter of hydrogen gas would present the maximum number of molecules. Question number 17. The number of moles of oxygen in 1 liter of air containing 21% oxygen by volume under standard condition is. So this 21% of 1 liter is 0.21 liter and 22.4 liter equals to 1 mole at STP. So we can say that 0.21 liter will be containing this much amount of volume. So calculated 21.21 liter, 0.21 liter contains how many moles? 0.93 moles. So option A is the answer for question number 17. Question number 18. Assuming fully decomposed, the volume of carbon dioxide released at STP on heating 9.85 gram of barium carbonate will be. So barium carbonate. When this barium carbonate dissociates, it gives you your barium oxide and quicklime. Sorry, carbon dioxide. Fine. So if 192 gram of barium carbonate gives 1 mole of carbon dioxide, that is for 22.4 mole, 9.85 gram of barium carbonate will give equals to this much mole of carbon dioxide, 0.05 mole of CO2, which is equals to 1.12 liters. So 1.12 is the answer for question 18. Question number 19. The ratio of the molar amounts of hydrogen sulfide needed to precipitate the metal ions from 20 ml each of 1 molar calcium nitrate and 0.5 copper sulfate is. Moles of this calcium to be prepared precipitate would be approximately 0.02. So how we can confirm this is, let us say, moles of calcium ions to form precipitate divide by 1000, so it will be 0.02. And this moles of copper to be precipitated equals to 20 into 0.5 by 1000. This would be 0.01. So molar amount of hydrogen sulfide will be in the ratio of 2:1. And remember, mole equals to molarity into volume by 1000. This will be in terms of ml. Anyway, so question number 19 would be 2:1. Consider the following statements. Atoms of hydrogen, oxygen, nitrogen, and carbon have identical properties but different mass. Statement 2. Matter is indivisible into atoms which are further indivisibles. 3. The ratio of nitrogen is to hydrogen in ammonia is 1:3 and nitrogen is to oxygen in nitric oxide is 2:1. 4. Dalton's atomic theory support law of conservation of mass. So which of the following pairs of statement is true according to Dalton's atomic theory? Think and tell the answer. See, for this statement 1, hydrogen and oxygen and carbon, nitrogen, they are all having different chemical properties. And for statement 2, it is true as per Dalton's postulate. For statement 3, the ratio of nitrogen is to oxygen in nitric oxide would be 1:1. For statement number 4, Dalton's postulate says atoms can neither be created nor destroyed. So 2 and 4 is the answer for question number, no, this one, 2 and 4. So option C is the answer for question 20. 21. How many moles of aluminum sulfate would be in 50 gram of the substance? You can easily find this from the relation we have, mole equals to weight by molar mass. So 50 by 342, it is equals to 0.14 mole. 28, 21D. 22, for 1 mole of the oxide, let's read together. Okay, experimentally it was found that a metal oxide has formula M 0.98 Oxygen. Metal M represents as M2 plus and M3 plus in each oxide. Fraction of the metal which can exist as M3 plus would be. So for 1 mole of the oxide, moles of M equals 0.98 and moles of O2 minus will be 1. Let us consider this moles of the unknown be M3 plus, which is X. So therefore what is left? Moles of M2 plus. Moles of M2 plus would be, subtract this value, the desired value is X. So on balancing we have into 2 plus 3x minus 2 equals to 0. So we can conclude that x equals to 0.004. Right, and in percentage, if you multiply this with 100, approximately it gives rise to 4.08. So answer for question 22 would be B. 23. 20 gram of a magnesium carbonate sample decomposed on heating to give carbon dioxide 8% magnesium oxide. What would be the percentage purity of magnesium carbonate in the sample? So this dolomite ore, but the magnesium carbonate, when it dissociates, it gives manganese oxide and carbon dioxide gas. So let's say 20 gram of this manganese carbonate forms about 9.52 gram of magnesium oxide. So since this 8 gram of magnesium oxide is formed, the purity can be found out by the relation 8 divided by this 9.52 into 100, which is equals to 40 percentage. So 40 would be the answer. 84, sorry, would be the answer. Next, 24. In aluminum fluoride contains 3 into 10 to the power minus 4 fluoride ions. And the number of formula unit of this sample are. So in aluminum fluoride, the number of fluorine is 3. And for 1 mole of this aluminum fluoride molecule, 3 fluoride ion equals equivalents to 1 formula unit of AlF3. So we can say 3 into 10 to the power 4 fluoride equals to 1 into 3 into 3 is equals to 10 to the power 24 aluminum fluoride units. So the answer would be D. Next, question number 25. Read the following and choose the incorrect statement. So both weight are measured in same quantities used for measurement. So this is correct. Mass and weight of a substance vary from correct. We are required to find the incorrect statement. Let's read question number 25, sub question C. SI unit of mass is kilogram and SI unit of weight is gram. So 25, D is the correct answer because mass of a substance is the amount of matter present in it, while weight is the force exerted by the gravity. Now question number 26, number of atoms in 558.5 grams iron is. So iron number of moles we can find easily. It has 558.5. So the difference is only 100. Sorry, only 10 moles. 10 moles corresponds to 10 Avogadro's atoms. So this number of 60 gram of carbon will be equals to 60 divided by 12. This gives 5 moles. So 5 moles of Avogadro's number, 26. Let us also read question number 27. What is the mass of precipitate formed when 50 ml of 6.9% solution of silver nitrate is mixed with 50 ml 5.8 sodium chloride solution? So this 50 ml of 16.9 50 ml of 16.9 solution of silver nitrate gives 1.69 organs. Let me erase. Okay. 50 ml of the 16.9 solution of silver nitrate would be 16.9 100 into 50. So this is equals to how many approximate? 8.45 gram of silver nitrate. Right, so mole can be found out from this relation. N mole will be 8.45 divided by 107.8 plus 14 plus 16 into 3. So it gives approximately 169.8. So divide this 8.45 by 169.8. So approximately you'll be getting 0.497. Fine. So this 550 ml of 5.8 solution of sodium chloride will contain 5.8 divided by 100 into 50 will be 2.9. So number of moles of sodium chloride would be approximately 0.0495. And for silver chloride and sodium chloride, when they react, the number of moles will be 7. And you can find from the answer, question number 27 is option C. Question number 28, which of the following is correct representation? So answer would be oxygen, nitrogen, and phosphorus. That is right. Question number 29. A compound made up of two elements A and B is found to be containing 25% and 75% B. What is the simplest formula of the compound? So this is the question. So let us make up a table here. Element, percentage, let us say atomic weight, then you can also mention your RNA, then simplest whole number ratio. So count here A elements, they are A and B type. Percentages 25 is to 75. And the atomic weights are 12.8, 12.8. 25 by 125, 75 by 337.5. So it corresponds to simplest whole number ratio means 1 is to 1 is to 2. 1 is to 1. That means AB is the answer for question number 29. Moving on to the next question, number 30. On analysis, a certain compound was found to contain iodine and oxygen in the ratio 2 is to 245 gram of iodine. What is the formula of the compound? So this moles of iodine present can be found out from this relation. You know already the atomic mass is 254. So the moles of the moles of hydrogen is equals to 254 by 127. So it gives rise to how much? 250. So it will be approximately 2. And the moles of oxygen would be 80 by 16. So it would be 5. So the formula would be I2O5. This is the answer. Question number 31. The following equation is a completely balanced equation. This is repeated again. Let's read question number 21. In a compound, carbon, hydrogen, and nitrogen are present in 9 is to 1 is to 3 is to 5 by weight. If molecular weight of the compound is 108, then this is also easy question. You first need to find the ratio of number of atoms in the molecule. That is 9 is to 1 is to 3 is to 5 is to 4. So empirical formula would be so this is the ratio of number of atoms 9 is to 12 1 by 10 1 by 1 divided by 3.5 divided by 14. So the value would be equals to 0.75 plus, okay, let's say 0.75. So if you take the simple whole number ratio, it will be in the 3 is to 4 is to 1. So empirical formula will be C3H4N. Okay. Now if the given formula is changed to C3H4N, you will be getting molecular formula equals to C6H8 and 2. So for question number 32, option would be C. Let's read question number 17. Arrange the number in increasing number of significant figures. This is also easy question. Yes. Increasing order. Correct. Okay. Let's move to question number 34. How many moles of lead chloride will be formed from reaction between 6.5 gram lead oxide and 3.2 gram of HCl? So the write the equation for the interaction we get. If I write the equation, lead oxide plus HCl gives H2O. Put here 2. And what is the given atomic mass? 220 gram. Then this is 673 gram. What about water? 278 according to the question. Now number of moles of PbO, that is lead oxide form, would be mole of PbO. PbO plus HCl plus PbCl2 plus water. So you know the atomic mass of this would be 233 gram. What about HCl? 70 gram. Lead oxide, it would be roughly 0.09. And right, should be 0. Yes, this would be 207 plus 71. So number of moles of lead oxide would be, you divide by the numbers, the atomic mass, it comes out to 0.029. The answer would be D. Question number 35. Equal weights of sodium chloride and potassium chloride are dissolved separately in equal volumes of solution. So molarity of the two solution will be. So when the weights of different solutes are equal in equal volumes of solution, the molarity is reverse related to molecular mass of the solute. The molecular mass of sodium chloride is less than potassium chloride. Hence, what happens? The molarity of the sodium chloride solution will be more. So question number 35 would be option C. 37. Which of the following is not the correct empirical and molecular formula of a compound? If the molecular mass of a compound is 80 and compound contains 60% of carbon, 5% of hydrogen and 35% of nitrogen. So let us see the question. 100 gram of compound will be present here, and the number of moles of nitrogen would be 35 is to 14. That is the mole fraction. That is, now we are getting a mole, that is 2.5, and the number of moles of hydrogen will be 5 divided by this 1.008. It gives 4.9. So number of moles is 60 with respect to 2.01. So it has 4.9. Now 2.5 is the smallest value. Division by it gives another ratio. So NHC, the given empirical formula would be, if this is nitrogen, hydrogen, and carbon, you are given in the ratio 1 is to 96 is to 96. So 1 is to 2 is 2. Now if we put this, you'll be getting C2H2N. The empirical formula will be 40 and molecular formula is molecular mass is 80. So molecular formula will now change to C2H5. So now it has C4H4N2. So option A is the answer for question number 37. Let us also read question number 38. A gas mixture, 3 liters of propane and butane on complete combustion at 25 degrees produce 10 liters of carbon dioxide. Find out the composition of gas mixture. That is propane is to butane. So let us see the way how they undergo combustion. First by propane. 5. These are fuels used in rockets and super fuel cells. 3 carbon dioxide, 4 water molecule. And if I say this is A and this is 3B, 3A, now let us write for butane, C4H10, you will be getting oxygen, carbon dioxide, and water. 13 by 2, and this would be 4, and this should be 5. Let us write here 3 minus A, here you're getting without, so 4, 3 minus A. So 3A plus 4, 3 minus A will be 10. So if you solve this, A equals to 2, that is propane, and 3 minus 2 will be 1, that is your butane. So 38 would be 2 is to 1, option A. Question number 39, arrange the following sequence. New, this mass of Avogadro's number of oxygen atoms is 16 mass of one atom of oxygen. And this, if mass of one oxygen is to be found out, it can be done by writing 16 divided by Avogadro's number. You're taking the unitary method, it comes out to be 2.66 into 10 to the power minus 23. Same formula you proceed, and mass of this Avogadro's number of nitrogen would be 41, and mass of one atom of nitrogen would be 14 divided by Avogadro's number. And similarly, for mass of 1 angstrom mole of oxygen would be definitely 1.6 into 10 to the power minus 10, and 1 mole of copper is 63, 1 mole of oxygen is 16, and 1 decimolar concentration of copper would be 63 into 10 to the power minus 10. So do the arrangement for question number 9. Okay, question number 40. When 30 liters of hydrogen and 30 liters of nitrogen are reacted, ammonia is formed and the yield is only 50%. The decomposition of the gaseous mixture will be. So this is a Haber's process, and in this reaction, nitrogen is the limiting reagent, and in this reaction 10 liter of this nitrogen will react with 30 liter of hydrogen, producing 20 liter of ammonia. So as a result of this, 50% undergoes composition of the resultant mixture will be 5 liter of nitrogen, 15 liter of hydrogen, and 10 liter of ammonia. You can do this easily by looking at the stoichiometric coefficient. The answer would be 5 liter of nitrogen, 15 liter of hydrogen, and 10 liter of ammonia. D is the correct answer. Question number 40. 41. How many moles of magnesium phosphate will contain 0.25 mole of oxygen atoms? So it says 0.25 mole. 1 mole of this magnesium phosphate contains 8 moles of oxygen atoms, and therefore 8 moles of this oxygen atoms will be having approximately 1 mole of magnesium phosphate. And in 0.25 mole of this oxygen atom, it will have 1 by 8 times the 0.25 mole of magnesium phosphate. So after simplifying, you are going to get the mole of magnesium phosphate approximately 3. Okay, so we'll conclude that D is the answer for question number 41. Question number 42. You read the question. 1.12 ml of gas is produced at STP by the action of 4.12 milligram of alcohol with a Greek nitrogen. The molecular mass of the alcohol is. So if I consider the alcohol as ROH and X is the molecular weight, this we have done in the chapter of alcohol, phenols, and ethers, and adduct forms, thereby giving your methane gas. So this 4.12 gram by 1000 gram of alcohol will produce 16 by x 4.112 into divided by 1000 grams. So methane actually obtained would be, this would be 16 into 112 by 2 to 400. So you can easily calculate this question. If I consider this as 16, 4.12 x into 1000 equals 16 into 12, 1.12 by 2400. So x would be 20, x would be 82.4. I hope it is understood. Let's read question number 2043. If 224 ml of triatomic gas has mass 1 gram at 273 and 1 atmosphere pressure, then the mass of one atom is. The given condition are standard conditions, and 224 ml has mass equivalence to 1 gram. So this 20,400 ml will have mass 100 gram, which indicates that this is molecular weight of gas and has Avogadro's number of molecules. And half for triatomic gas, you have to multiply Avogadro's number by 3. And weight of one atom will be, since it is given in terms of grams, you need to write it in 100. 100 by 3, since this is given as triatomic, 6.22, 10 to the power 23. So when you do the calculation, the answer will come approximately 5, 10 to the power minus 23. So C would be the answer. So in the exam, you need not do the exact calculation, just go with the approximate value. A compound contains atoms of 3 elements A, B, and C. If the oxidation number of A is plus 2 plus 5 for B and C is minus 2, the formula of the compound will be. So it has to be, okay, the sum of this oxidation state must be equal to 0, which is given by this formula A3 BC 4, 2 times. So can I rewrite this as A3 B2 C8 all into 6 plus 10 minus 16. So this definitely equals to 0. So the formula of this will be option B. And as usual, you try solving this last question by yourself and give the answer in the comment section. Thank you for joining up to then. We shall meet in the next episode, and happy learning.